All right, let's get started with 9.1 and 9.2 systems of linear equalities in 2 and 3 variables. So we looked at this in the preview, but let's take a look again. We can have 3 different ways to solve a system of 2 equations. We could have the 2 lines cross, which would give us 1 solution. If they are parallel, we would get no solution. And if they are lying on top of each other, they touch in every possible place. So that's infinitely many solutions. All right, let's go ahead and learn to solve these. So we learned how to do substitution and elimination. Let's just review substitution here. So if we wanted to get x by itself, we could subtract y on both sides. We would say x equals 8 minus y. And so we would have 3 times that from the other equation. We're going to get what x equals and plug it in and substitute. So we would say 8 minus y instead of x. Minus y equals 4. We have 24 minus 3y minus another y equals 4. And so we would have, if we subtracted 4 from both sides, we would have 20 equals, if we add 4y to both sides, 4y. So y equals 5. And we'll say x plus y equals 8 from the original equation. If y is 5, then x equals 3. Go ahead and write this in coordinate notation, 3, 5. All right, determining substitution by substitution, a system has no solution. I'm going to go ahead and do elimination for this one, actually, just to show that we have 2 options. And so elimination, remember that we can multiply if we need to. So we'll say 2x minus 2y equals 4. And then let's subtract straight down. So those cancel. Those cancel. We're left with 0 equals 6. That is never the case, so we are going to have no solution. All right, infinitely many as well. This one is ready to go for elimination. If we add straight down, that'll cancel and that'll cancel. We got 0 equals, and that cancels also. 0 equals 0. That is always true. So we have infinitely many solutions. Your turn. All right, on A, we could multiply the top equation by 2 if we're using elimination. We would have 4x plus 2y equals 6. If we subtract straight down, the x's and the y's both cancel. 0 equals negative 2. No solution. On the second one, I would multiply the top by 4. We're going to have 4x minus 4y equals 8. So we're going to, if we subtract straight down, get positive y equals 2. Let's plug this back in. X minus 2 instead of y equals 2. X equals 4. 4, 2. And lastly, let's go ahead and multiply the top equation by 2. So we'd have 2x plus 4y equals 2. These are exactly the same. So if we subtract down, we'll get 0 equals 0. That's infinitely many solutions. Okay. All right, so in the textbook, they have a number of examples to do elimination. I think you guys have the idea without going through a bunch of more examples. So let's go ahead and move along to 3 variables. Okay, so 3 variables graphically looks like this. So if you have 3 variables, you're talking about operating in a plane. And where can those planes intersect? They can still intersect in a single solution. They can be parallel to each other, or they can intersect not all in a common place, though. So we could have no solution. Or they could all 3 intersect in a line, and this would be infinitely many solutions along that line of intersection. All right, so for the purposes of our course, we're not going to worry about what that line of intersection is, just that there are infinitely many solutions. All right, so we've talked about this in class, but just to review, how do we reduce, or how do we get a solution for 3 variables? First, we need to take our 3 variables and cut it down to 2 variables. That's the key. And once we have that, we will solve it like normal for 2 variables. And then plug back in and solve. But the key is get it down to 2 variables. So let's start with this. I see probably the easiest option here is matching up the y's with each other. So I'm going to go equation 1 with equation 2. 2x plus y plus 8z equals -1, and x minus y plus z equals -2. Let's go ahead and add straight down. So we get 3x, the y's cancel, plus 9z equals -3. And then let's go ahead and match up equations 1 with equations 3. Could have picked 2 and 3, but I like equation 1 because it's a positive y. 2x plus y plus 8z equals -1. 3x minus 2y minus 2z equals 2. Going to need to multiply this top equation by 2 so the y's match up because we're crossing out y's. So we would get 4x plus 2y plus 16z equals -2. And we are adding straight down. So we get 7x, and the y's cancel, plus 14z equals 0. We now have 2 equations and 2 variables. So we're going to line these up. 3x plus 9z equals -3, and 7x plus 14z equals 0. Let's go ahead and multiply the top equation by 7 and the bottom equation by 3 to get 21x plus 63z equals -21. And we'll end up with 21x plus 3 times 14 is 42. Z equals 0. If we subtract straight down, those cancel. We have 21z equals -21. Isn't that convenient? So z equals -1. Let's go back in and solve. I'm going to go back to this one right here. Could have picked this or this one. So 3x plus 9 times z. So this is -9 equals -3. So 3x, if we add 9 to both sides, we're going to get 6. So x equals 2. And then let's go grab any of the original equations. I'm going to grab this one. Looks like the easiest. X minus y plus z equals -2. So 2 minus y minus 1 equals -2. So this is 1 minus y equals -2. Let's subtract 1. We'll get -y equals -3. So y equals 3. 2 for x, 3 for y, -1 for z. Okay. All right, so as you can see, this takes a lot of room on your paper. Give yourself some space. We are going to learn later in Chapter 10 some ways to make this quicker and simpler, but doing it by hand, this is what you've got to do. So give yourself some space. So your turn, and this will wrap things up for this video. All right, let's do x's in this case. Simple enough to do that. 1 and 2. You know what? Let's do y's, actually, since we already have those y's matching up. 2x minus y plus 3z equals -1. And x plus y minus z equals 0. And so we're going to just add straight down. 3x plus 2z equals -1. And we'll go with number 2 and 3. So we're going to, and I'm going to need to multiply equation 2 by 3 all the way through. So 3x plus 3y minus 3z equals 0. 3x plus 3y minus 2z equals 1. Let's subtract straight down. So the x's cancel and the y's canceled here. And then we ended up with -z equals -1. Because when you minus negative, that's positive. So z equals 1. So we got that right away. We can skip the middle step. Go back here. Let's plug it in. 3x plus 2 times 1 is 2 equals -1. 3x equals -2 minus 2 equals -3. X equals -1. Let's go back to the original. We'll go back to this one. X plus y minus z equals 0. So -1 plus y minus 1 equals 0. So that is y minus 2 equals 0. Y equals 2. -1 from the x. 2, 1. All right, we will see you in class next time.